Alright everybody, so today we're talking about inverses of relations. And if you want to know more about relations or functions, then check out some other videos like what is a function and what is a relation, and there'll be more in-depth discussion about the background knowledge that's leading up to this video. Okay, so first of all, before we try and find an inverse of a function like this one, let's talk about, well, what is an inverse? So an inverse happens when the inputs and outputs get switched. And there's lots of different names for inputs and outputs that you'll find throughout your years in mathematics. Inputs could be called domain. Inputs are represented by the letter X. Inputs are another name for inputs is independent variable. So there's lots of different ways of calling it, but the input and output, in the case of an inverse, the input and output get switched. Okay? In this equation, the output is represented by f of x here. This is the output from the function, and the input into the function is x. Okay, so, and what is a relation? A relation is just any relationship that has a beginning set and an ending set. Again, these are other names for inputs and outputs. So beginning set, that's domain. Ending set, that's range. So now that you have some background knowledge about what happens in an inverse, the inputs and outputs getting switched, let's talk about how to actually find an inverse of a function. So here's a function, it's a linear function. Well, if inputs and outputs get switched, and this represents output, and x represents input, then those two get switched. Typically, the first step that you'll see, like in any textbook, for finding the inverse is, instead of writing the output as f of x, we write the output as y. And I think this is just because it's easier to work with. So we can rewrite this as y is equal to 3x minus 2. Y meaning the output from this function, and x meaning the input into this function. Okay, so inverse means inputs and outputs get switched. So that means that y, in the case of the inverse of this function, y will become x, and x will become y, because inputs and outputs are getting switched. So in place of y, I'm going to put x, and in place of x, I'm going to put y. Okay, and now our task is solve for y. Get it back into this form that we had before. So I'm going to start moving things away from y, and if you want more on solving, then go back and check out one of the other videos on solving one-step or two-step equations. Okay, so moving things away from y, I'm going to add 2 to both sides of the equation to get x plus 2 is equal to 3y. And now I'll divide both sides by 3. And we'll have y is equal to x plus 2 divided by 3. So I'm going to rearrange the equation. I'm going to flip the two sides. Y is equal to x plus 2 divided by 3 because that's the way we were comfortable with seeing it, typically the way we see it. So y is equal to x plus 2 over 3. And now we just have to tell other mathematicians that we found the inverse of a function. By the way, little side note, sometimes inverses of functions are not functions themselves. In the case of a linear function, when you find its inverse, its inverse will also be a function. But sometimes for other relations, like the quadratic function, when you take the inverse of a quadratic function, you don't get a function back. Just something to keep in mind. Maybe we'll make some other videos about more complicated functions. So now, at this point, you have to tell other mathematicians that you found an inverse of a function. And the way you do it is by using this symbol. Okay? That's the symbol that we use for the inverse of a function. It looks like it's f to the power of -1, but it's not. It doesn't really represent an exponent. It's just the symbol that we use for the inverse of a function. So we find out that the inverse of the f function is equal to x plus 2 over 3, and that's the end of the story for inverses for today.